We now get to our final section, which is section 6, talking about how to name and write formulas for acids. Acids have their own special set of behaviors, and so they have their own special set of rules for naming and writing. So first of all, what is an acid? An acid is a compound that, when it's dissolved in water, it will produce hydrogen ions. It's the hydrogen ions that make something acidic. When we say dissolved in water, what we mean is it is aqueous. So when we see HCl in the gas form, we learned in the last video that we call that hydrogen chloride. But when we see HCl dissolved in water, in other words aqueous, it now has a different name, hydrochloric acid. In the picture we can see that. Over here the hydrogen and the chlorines are still bonded together, so it's hydrogen chloride. But once we add it to water and everything ionizes, now you have these hydrogen ions, which makes the solution acidic. Now there's two terms we want to be familiar with as we go through and start talking about acids. There are monoproduct acids and then polyproduct acids, specifically diproduct and triproduct. What does all that mean? Well, hopefully you're familiar with the prefixes mono, poly, di, and tri. But what does product mean? Product is actually coming from the word proton. Why are we talking about protons when it comes to acids? Well, let's think about this. The element hydrogen has one proton, one electron, and 0 neutrons. But when hydrogen becomes an ion, how does that change our subatomic particles? It changes the number of electrons. Specifically, it gets rid of that one electron, and now it has 0. So really, isn't a hydrogen ion the same as just a proton? That's why they often get used interchangeably. So, to back up, when we say we're looking at a monoproduct acid, it means it only has one ionizable hydrogen. Specifically, the hydrogens at the front of the formula. So, HNO3, HCl, even HC2H3O2. Notice the hydrogens at the beginning of the formula, there's only one. Versus polyproduct acids have more than one. Specifically here, H2S, it has 2, so di. Or H3PO4, it's triproduct. So that'll help us figure out what kind of acid we're looking at. So now we get to how do you name them. Well, before we get started with that, there's actually there are two types of acids, and I'll write this off to the side. There are binary acids, and there are what we call oxoacids. And each one of these is going to have their own separate names. What do they have in common? Well, in terms of their formula, both of them are going to start with hydrogen. Acids will start with hydrogens. Also, they will both be in the aqueous form. But what makes them different? With a binary acid, remember what binary means. Binary means 2 elements. Well, if one of them is hydrogen, then what's attached to the hydrogen must be another element. Versus an oxoacid, it's not going to be an element, it's going to be a polyatomic ion with oxygen. So, keeping those two types of acids straight will help us with the naming. We're going to focus on this slide with the first type, the binary acids. So, when you're taking a look at a binary acid and you're asked to name it, how would you do that? The first thing we would do is we would change the hydrogen to hydro. Then take the root of the second element and add the suffix "ic." Finally, end with the word acid. So let's take a look at an example. HBrAQ. Couple things. It starts with hydrogen. It's aqueous, so those two things tell me it's an acid. And specifically, it's a binary acid because there's only 2 elements, hydrogen and bromine. So, I go into my naming rules. I'm going to change hydrogen to hydro. Bromine is the element. I'm going to take the root of that and change the ending to "ic." Finally, I'll add the word acid, making it hydrobromic acid. Let's take a look at some other examples. Right here, we have hydrofluoric acid. So it's an acid, so it's going to start with hydrogen. It's going to be aqueous. But what's attached? Well, what element sounds like fluoric? That to me sounds like fluorine. Make sure when you're writing the formula, you have enough hydrogens to balance out the anion. If fluorine's -1 and hydrogen's +1, then it makes sense we only need one of each, HF. So HF aqueous will be our answer. Second one, we have H3PAQ. So it starts with hydrogen, and it's aqueous, so I know I have an acid. Specifically, it's a binary acid because there's only two elements, hydrogen and phosphorus. So let's go ahead and name it. Change the hydrogen to hydro. It doesn't matter that there's three of them, it's still going to just change to hydro. The element is phosphorus, but I'm changing the ending to ic. So hydrophosphoric, and then finally end with the word acid. Lastly, hydrosulfuric acid. All acids start with hydrogen, and it's going to be aqueous. Now I say, what element is attached to the hydrogen? Well, what element sounds like sulfur? The element sulfur. You notice we actually don't change the ending to sulfur, we actually leave the whole word. So it sounds better than just saying sulfic. But nevertheless, I write sulfur. Now before I'm done, make sure that this is written correctly. Sulfur has a -2 charge. Hydrogen has a +1 charge. So I need two hydrogens to balance out the one sulfur. So that would be the formula for hydrosulfuric acid. Now that we have a good understanding about how to name binary acids, now let's look at oxoacids. Oxoacids are acids that contain oxoanions, which, I said earlier, are simply polyatomic ions with oxygen. So, for example, if nitrate were to be in an acid form, that would make the oxoacid HNO3AQ. If sulfate were to make an acid, it would make the oxoacid H2SO4. Notice the two hydrogens just because it has to balance out the sulfate. Alright, let's take a look at how we name these. One of the biggest differences between binary acids and oxoacids is oxoacids do not start with hydro. Instead, they actually start with the root of the polyatomic ion. Now, the problem with polyatomic ions is that a lot of them sound the same. For example, we have things like nitrate versus nitrite. If we change the endings to both of them simply to ic, that's not going to indicate to us which one of those polyatomic ions we're looking at. So, we have to have some steps here. We're going to add the appropriate suffix. If the polyatomic ion ends in ate, we will change the ending to ic just like we've done before. But if the polyatomic ends in ite, we will change the ending to us, O-U-S. I like to think if you ate it, it would taste icky. The only one I've been able to come up with for the second one is, you want to party with us? Ite? Really bad and stupid and actually terrible. And that I can't get away with that for much longer. But nevertheless, it'll help us remember. Finally, we'll end with the word acid just like we've done in the past. So let's take a look at some examples. We have H2CrO4 aqueous. Starts with hydrogen, and it's aqueous, so it is an acid. But notice what's attached to the hydrogen. It's not simply an element, it's a polyatomic ion, specifically an oxoanion. So, let's go into my naming rules. First thing, we do not start with hydro. The hydrogen gets completely ignored in the name. So, let's go right into the name of the polyatomic ion. CrO4 is chromate. We take chrome, but we change the ate ending to ic. Finally, we add the word acid to become chromic acid. For HNO2 aqueous, starts with hydrogen, and it's aqueous, so it's an acid. But look at what's attached to the hydrogen. It's a polyatomic ion. So, we need to use our oxoacid rules. Ignore the hydrogen completely in the name. Go right into the name of that polyatomic ion. The polyatomic ion NO2 is nitrite. The ite gets changed to us. finally end with the word acid to become nitrous acid. So let's move to example 10. Real quickly, as a review again, let's remind ourselves how you can determine the difference between binary and oxoacids. What do they both have in common? They both start with hydrogen, and they're both going to be aqueous. What's going to be different between them? For binary, it's going to be an element attached. And in terms of the name, it's going to start with hydro. For an oxoacid, it has a polyatomic ion attached. And it is not going to start with hydro. So that's how you can tell. As you go through this example 10, also be wary of making sure that you're looking to see if it actually is aqueous, or maybe it's just simply in the gas form and it needs to be named accordingly. So let's go through and do these together. If you want to do this on your own and then check your answers, hit pause now and try these on your own. I encourage that. You can always check your answers and make corrections when you resume the video. Okay. So HCl gas, I notice it's a gas, so this is going to be hydrogen chloride. I'm not going to name it with acid naming rules. HCl4AQ has hydrogen, has aqueous, so this is an acid. It's a polyatomic ion. What is ClO4? It's perchlorate, but I'm going to change the 8 to ic and then add acid. So it's perchloric acid. NO2 aqueous. It's an acid and it's got a polyatomic ion. NO2 is nitrite. So the nitrite becomes nitrous acid. H2S, but it's gas. So this is just simply hydrogen sulfide. The last one in this column, HBrAQ. It has the hydrogen and it has the aqueous, so it is an acid. And it only has an element attached. So it's going to start with hydro. Bromine becomes bromic. And then we end with acid. On the right side, we're given the names. Sulfuric acid. Well, I know it's an acid, so it starts with hydrogen and it's aqueous. But there's no hydro, so it must be a polyatomic ion. What polyatomic ion sounds like sulfuric? Well, the ic ending tells me that it's coming from sulfate, which is SO4. And since sulfate's -2, I need 2 hydrogens. Hydrogen bromide. Notice that's not an acid, so I'm just going to write HBr, and it's in the gas form. Chloric acid. Well, it's an acid, so it starts with hydrogen, and it's aqueous. There's no hydro prefix, so it's got to be a polyatomic ion. What does chloric sound like? Replace ic with 8. It's chlorate, which is ClO3. Chlorate is -1, hydrogen's +1, so it's good written just like that. The next one, hydrochloric acid. So it's still an acid, so H and AQ, but it has the hydro prefix, so it's a binary acid. What element sounds like chloric? Chlorine. And hydrogen and chlorine are +1 and -1 respectively. Finally, chlorous acid. It's an acid, so it starts with hydrogen, and it's aqueous, but it has no hydro prefix. Let's replace us with ite. So chlorite is the polyatomic ion here, which is ClO2. Chlorite is -1, hydrogen's +1, so it's good to be written just like that. That wraps up not only this section, but this topic. Great job, you guys. We'll see you in topic 6.